to go. So yeah, so I think for today, I just kind of want to review what we did with Scaffold-ETH, how to set it up real quickly, and then I'm going to kind of go through kind of the primitive data types, because we didn't actually do a video on that or anything like that. So this would normally be a time for Q&A, but I think we'll just utilize this time to review the primitive data types, since we only have a limited number of people that were able to make it. So we just to review, you need to check out the directory using git. You do a yarn install that's going to install the dependencies. You're going to do a yarn chain to spin up your hard hat chain using Scaffold-ETH. And then in a new window, we need to run yarn start, which is going to essentially spin up React. And then we're going to do a yarn deploy to actually deploy our application. So we'll give that a second to spin up. Let me just make sure there's no one that needs to get entered into the channel. Cool. All right. Awesome. So yeah, once the app is up and running, give it 1 second here. The React takes about a minute to start, so I don't know why it takes so long. For some reason, React is kind of slow. So if you do want to follow along with any of these steps, I basically created those and I put them on my Bitbucket. I'll also share them in the channel. But my Bitbucket has kind of like a Scaffold-ETH demos README file here in the root. So you go all the way back to the main menu, and you can see kind of like some kind of walkthroughs. So the one that I did last time for you guys was the one from Hack Money, and then what we're going to be going through today is the one for primitive data types. Looks like someone else might want to get in. Hello, thanks for joining. So I'm just going to go through kind of the primitive data types quickly and kind of show a little bit about how you can kind of explore this stuff with Scaffold-ETH. If anyone has questions, feel free to interrupt me and ask questions as we go, okay? So I've already got React up and running. It should be up and running now. So we should be able to see our default smart contract, which is here. And what we can do now is we can actually come in here and kind of see what it looks like to create primitive data types, right? So we already have one primitive data type here, which is a string. Let's create like a different one, right? So let's actually create a bunch of kind of default values. I'm just going to paste these in so you kind of see what these look like. But essentially, when you define a primitive data type, you have to specify whether it's publicly available or whether it's not. If it's publicly available, it's available outside of the contract. So other contracts can see that data. Users that are reading the smart contract can read that data. If you don't make it public, it will only be available internally in the smart contract. And it's important to know that if you define a primitive data type, it has some default settings, right? So a Boolean is automatically going to default to false. A uint is always going to default to 0. Same with an int, an integer versus an unsigned integer. An unsigned integer is essentially anywhere from 0 up to a certain max limit that you specify. And it's also important to note that if you specify just uint, it's going to use the largest size uint available, which is uint 256. So best practice actually is to type like this, where you actually specify and kind of hard code it, because it's easier to read. It's a little bit more implied, but that's just kind of what you get as the default. And then same thing goes for an address. If you don't specify an address, you get this kind of string of zeros, which is kind of the base kind of address that's empty, essentially. So I mentioned before that, sorry, someone else needs to get in. Let's see. Oh, thank you for joining. So just a heads up, I'm just going through kind of the primitive data types right now, and if anyone has questions, it's kind of open hours right now, so you guys can ask me questions, just let me know. So again, so if you want something to be available internally only, you would just make it not public. If you want something to be available outside the smart contract, then you need to make that public, right? Also, like I said before, it's important to understand the size. So again, a default uint is going to use the maximum size uint available, which is like 256. If you wanted to make it a hard-coded amount, you could like do 128, 64. You could do 8 if it was a really small unsigned integer. And when it comes down to actually like the size of each unsigned integer, in other words, like the maximum amount of data that you can store in that integer, then this is kind of what it looks like. I'm just going to paste these in because it's easier. So you can see here that we have a few different unsigned integers, 8 all the way up to 256. So this gives you an idea of like how much data can be stored inside of each unsigned integer. So like in this case, an 8 uint 8 can store up to anywhere between 0 and 255. So if you were to try to make this 256 and then deploy this, it would give an error. Actually, let's do that. Let's go ahead and deploy that change. You can kind of see what that error is going to look like. So you can see here that we're going to get an error. It's going to say like, oh, the literal size of that variable is too large to fit into it because it's only a 8-bit. So we would actually need to come over here and actually change this down to 255. And then we deploy that. And we're also getting an error with this. Is same thing, we're getting a too large error for this other uint, which is this one here. So yeah, I probably did some math wrong, but you get the idea that, depending on the size of the variable, there's a limit to how much you can put in there. So that's something to think about when you're defining your variables. Really, from like an optimization standpoint, it makes sense to try to limit the size of the variables as much as possible because it affects transaction price. If you're like working with large amounts of subsets of variables with like large amounts of data in them, or maybe you just want to limit like the overall behavior of your smart contract. Like you don't want to allow people to mint more than, I don't know, 65,000 NFTs or something like that, then it would make sense for you to use a uint 16 because that number is really ever going to exceed that anyways. So it's kind of just another like fail safe to where you can like kind of limit the contract in some sense. Hopefully that makes sense. Any questions about this so far? Everyone's waiting in the room. Okay. Someone else just popped in. Let's allow them inside. Thank you for joining. If you just joined, I'm just kind of walking through some like primitive data types so that you guys kind of can see how those are defined in Scaffold-ETH. So let's get rid of this stuff for right now, and let's deploy just these changes. So these are just some like basic, various primitive data types. We have Boolean, unsigned integer, and an address. So now that we've deployed those in Scaffold-ETH, that was successful. So let's take a look at it. So you can see here that what the default values are. Again, so a default contract is all zeros, pretty much. Default Boolean is always false. Default integers and unsigned integers are always 0. Yeah, those are pretty much the defaults. You can also see like what a minimum and maximum size of a particular variable is going to be set at by using these kind of like modifiers. So in this case, we have a minimum integer and a maximum integer. And so we can actually just save those. So what this is saying is, okay, define a variable, call it minimum integer, make it type int with a minimum amount. And then this one here is a max integer, type int with the maximum, basically like the maximum amount of data that you can store in there. And so if we deploy that, we can also see what that would look like in Scaffold-ETH. Let's make sure it deploys. That deployed. So there we go. So we can see that for an integer, which is int 256, it looks like it's the default, This is the max amount of data that you'd be able to store in there, right? A positive value of whatever crazy amount this is, and then a negative amount of this amount, right? Also, if you're going to do anything with addresses, it's important to note too that you need to make them payable. So in other words, like if you want them payable, like if you want to be able to pay out to specific addresses in the smart contract. So this would be a publicly available address, but if you want to actually transact with it on through your smart contract, it needs to be payable. Okay. Yeah, so that's pretty much it. If you wanted to deploy a value at the time that the smart contract was deployed, you might do something like this, where you would first define the type of variable that it is. So in this case, it's a state variable. And then you could basically, inside of your constructor, we talked about the constructor last time, but the constructor is essentially, it only is executed at the time that the contract is deployed, and then it's never, so it's kind of like a way for you to like do like store information at the time of the deployment. You can hard code it like this, or you can pass it over inside of the constructor. So you could do something like uint number, and then you could actually pass it here like this. And then you could then just deploy this at the time that you're going to deploy your smart contract. And if you're going to do that, you need to edit your deployment script again. So there's this deploy script. We looked at it briefly the other day if you were on my other call. And the important thing is the args here. So you'll see, the deployer can take in arguments. So you can like have a name, right? So you could say like Kevin or something like that. Maybe I have like a certain token and I'm going to launch and it's going to be called, I don't know, like Ninja token or something like that. Ninja. And then maybe I want to do like a certain supply. So then I would also pass in like 777 of them, right? So in this case, I could pass in these different variables to the smart contract. So we could do like something like, where's the other one? What is it? A string name, something like that. Uint underscore number. I like to do like, so generally it's good to do lowercase variable names. If the variables are used only like internally, then I usually like do an underscore. That's just my own personal thing, so that I can keep track of what variables are like used outside of functions. But if it's something like that's internal to the function, so in this case it's internal to the constructor, then I'll do like an underscore just to keep track of that. And then we could do something like this, like string public, I don't know, token name or something like that. And then we could define this token name equal underscore name, like that. So I could pass these in. So this should work. If I was to do this right now, let's save it. Let's see if it works. I think I probably did it wrong. Going a little out of scope here of my walkthrough, but let's see if it works. It didn't work. No, what happened? Payable but not equal. Oh, maybe address payable public. Cool. Oh. No, that's why I didn't name it here. Like that. Do that one. Finding syntax corrections in my work. Okay, so it must be storage or memory. Oh, so we have to define how that's coming in. So we can do like string memory, which means we just stored in memory as the variable gets passed to the constructor. If you do storage, it's going to be permanently stored on the blockchain. So you always want to try to use memory. If you want to even save more gas and more utilization, then you use call data. So let's try this again. Let's see, address payable public. Maybe I need to do public payable. Let's try that. I'm trying to remember. I might have to just get rid of that line. I don't know what's wrong with it Okay, well, let me just get rid of this one for now. I'm not sure what I'm doing there wrong. Let's try it again. Yeah, it worked. Okay, so we deployed. So you can see how I was able to pass the name of my token and a set amount or something like that into the contract. Really, I'm just defining some variables. I'm not really doing anything crazy, but essentially I've defined the variables here as state variables. Then I pass them into the constructor here. And then in this section here, then I'm actually defining them at the time that the constructor is kind of like run. So again, this will only happen once, and then they'll be stored as storage. But again, this part is just in memory, so it's only going to use the string in memory to pass it. So it's just going to utilize a set amount of memory, essentially. So now we can take a look at the contract and see what do we got here. So we have the address that we defined. We have the default, which is going to be empty. And then we have, here we go, we got the two variables that we created. So 777 and then a token named Ninja. So you can see how you can kind of like do some deployments there using that. I wanted to cover, the defaults. I talked about the defaults. Okay, so there's three kinds of variables. Let me increase this a little bit here. There's state variables, which are variables that are permanently stored in contract storage. Those are the most expensive pretty much thing that you do on the blockchain because it's actually having to store that data. So you only want to store what you absolutely need to in these state variables. The less you put, the cheaper that your transactions will be. Variables that are local are only inside of the function. So if you define a local variable, like an example of a local variable is here, where we have this like unsigned integer, and it's only used to make a calculation inside of the function, and it's actually never technically stored. I mean, it's stored in the contract because it's hard-coded here, but the transaction of when you define that variable is never stored inside of the on the blockchain. So it's kind of a cheaper way for you to define a variable and use it inside of a function. And then you have global variables. And global variables are kind of like these things that are kind of like preset and available, like anything related to the block or the block hash or the difficulty, stuff like that. Anything that's in the message, there's some default ones like the sender, which we talked about, the message value, which is how much value is coming across. And then you have these like gas price and origin as well. And then the last thing that I want to talk about real quickly is, and then we'll pass it off for questions, is the scope of the variable. So I talked about it briefly, but public is available internally as well as through the messages. Yeah, so this is what you want to use if you want to make something available outside of the contract. If it's internal, they're only going to be available internally inside the contract. And so again, it's something that maybe you would make like private. You wouldn't want anyone who can view the functions or execute the functions to see that data. Again, it's still going to be in public view because the smart contract is there, but it's at the time of processing, it's not. And then something that's completely private is, yeah, I guess the difference between private and internal is. Yeah, so I'm trying to struggle to explain the difference between these two. But most of the time, if you're going to use the variable within other functions, then you define it as internal. If you're defining something outside of a function, I think, and you don't want it publicly available, then you set it as private. I think that's kind of the best practice. Really, I mean, most of the time, you're going to be probably not caring too much about this stuff because, again, everything is technically visible on the blockchain at the time that you define it inside the contract. So if you're making changes to a variable and you don't want to, you want to conceal that in some way, then you try to make it private. Cool. All right, so let me stop sharing my screen and then see if anybody has questions. Does anyone have any questions about the content, or has anyone gotten like gotten stuck or any feedback? which contract? The one from this session or the one from the very first session that I did? From this session? Oh, okay, yeah, sure. So I also have, well, I just noticed that I had some errors in my contract. So so it could be that it's my fault actually. But yeah, let me share my screen real quick, and then let me show you what I got. And yeah, I was having the same problem. I don't know what syntax that I was using that was wrong. I had to find something wrong. Let me put it in here. Hold on. Let me get the right syntax real quick. I don't know what I was doing now. Yeah, so it should be like address payable public. Actually, maybe address payable. I guess you don't need to make it public. You just need to make it payable. Let's try this. Now I'm like confused. Let's just grab. Let's try to deploy that. Yeah, I'm having some issue. I don't know why it's giving me issues. Hold on one sec. I was trying to look on the thing here to see if I'm just like doing something wrong. So I'm wondering if you just need to do like just payable. Yeah, I'm not sure why it's not working. Yeah, I'll have to get back to you. I'll post something in like this the Discord channel after I fix it. Yeah, sorry, I don't know why it's not working. I feel like I'm doing something really stupid, like wrong. I don't know what it is. Yeah. Okay. Anyone else have any other problems or have any questions? Okay, cool. Well, I think we can call it then. Yeah, so I think what we're gonna try to do is keep doing this kind of like a weekly session. So we're gonna have these scheduled out, and if ahead of time, if you guys have questions, post them in the Discord channel, and then I'll try to like be prepared to like cover that content, so it's a little bit more like focused on what you guys are having issues with, or what you're trying to learn. So, okay, guys.